guys, welcome to your first online math lesson, I guess. So today we are going to be starting with chapter 8. I know we're skipping around a little bit from where we left off, and part of that is for distance learning, and part of that is because of our Algebra 1 standards. So don't be worried that we didn't finish chapter 7 quite yet. So we are going to start with chapter 8, and we're going to start with 8.1. which is adding and subtracting polynomials. So before we can actually get started with this one, we're going to have to learn some terminology because we don't know much about polynomials right now. So to get started, let's get some vocabulary. So we are going to go ahead and get started with using correct terminology because the more of it we learn, the easier it's going to make things long term. So monomial is a term that we already have. It's a number that is a variable, or a product of one or more variables. And so we got that term back in chapter 7.1, when we started talking about some exponents and our exponent properties. So remember, with a monomial, there is no addition or subtraction, just multiplication. And our exponents had to be positive. We couldn't have any division by variables. We could have division by fractions, which is why we are allowed to have c divided by 3, because c is the only variable, which is like c to the first over 3. So our next term is the degree of the monomial. So the degree is going to be the sum of the exponents of its variables only. So if there's only one variable, we're not going to worry about it. So the degree of this first monomial is going to be 2 plus 1, which will equal 3. Now, on this second monomial, there's only one variable, and so I don't have to deal with adding any of them because my degree will be 3. Our next term is coefficient. Coefficients are the numbers in front of all the variables. So for example, in negative 5x squared y from above, the only coefficient is negative 5. Or, for example, the 6x cubed from above, the 6 is my coefficient. Okay, so our next term is polynomial. So a polynomial is a monomial, or a sum or difference of them. So while a monomial could not have addition or subtraction, polynomials can. Okay, so this example down here is a 1, 2, 3, 4. It has 4 monomials in it. So this one has 4 terms. But each term individually is a monomial. And I can add or subtract them. I'm allowed to do either. Okay. So if you need more time to get information from the slide, press pause, because I'm going to go ahead and move on to the next slide. So, more vocabulary. I know, we have a lot of it. So, with the standard form of a polynomial, and we'll do some examples of this in a moment, is going to mean the degree of its monomial term, so each term, is going to decrease from left to right. So if you look at this example down below, okay, I have a 4th degree, a 2nd degree, a 1st degree, and the last one is a constant. It doesn't have one, and so 1 is degree 0. Okay, and so that one is in standard form because I went 4, 2, 1, 0. I didn't have to have a degree 3, okay, but it did let me go, and I decreased from left to right in that order. So the degree of the polynomial is going to be the degree of the highest term out of all of them, okay? So for this one particularly, we have a 4, 2, 1, and a 0. Which one of those numbers is higher? that would be 4. So 4 is the degree of this example. Okay. The leading coefficient, which is our last vocabulary term on this slide, is the number in front of the highest degree, or the first term when in standard form. So using the example from above, 3 is going to be the highest one, and that's because it is in front of the x to the 4th term, which has the highest degree. So let's go do some examples with some of these so we get a little bit more practice. So with polynomials, we'll give them all 2 names. Okay, so these are names that you'll be using all throughout Algebra 1 and a lot throughout Algebra 2. And it depends on what class you take your senior year, would depend on which one you would need, how much of this you'll need. So with this one, the degree is going to be one name, and then it'll get another name by the number of terms. So it'll get both, okay? So, for example, my handwriting is not the greatest on here. I apologize, guys. So if I give you, it was what, 3x to the 4th plus, I don't remember the rest of it, so I'll make one up. 2x cubed plus 6x. Okay, so this one would get 2 names. This one would be a 4th degree because this one's polynomial is degree 4, and it has how many terms? This one has 3, so this one is a 4th degree. Trinomial. So what that means is I got 2 names for this one. So you'll always pick one from each table in order to use them. So let's go write some of these in standard form and use our terms. So first off, when we go, we're going to write in standard form. Oh, sorry. We're going to write them first in standard form, and then we're going to classify them. So first off, remember when we rewrite these for standard form, we need to write it to where the sign in front comes first. So for this one, this would be negative 2x. 5 is positive out here, so I'm going to write plus 5. Okay. If you look back at our table now, first I need to decide my degree. So I have degree 1, and I have 2 terms. So because of that, this one is a linear binomial. So linear comes from that degree table, and binomial came from our term table when we give them names. Okay, so when we do combine them, so if you look at the next example, I have 4 terms right now, but I'm not in standard form. So I actually can't decide how many of what I have. I first have to go and write it in standard form. So standard form says, well, if I have these pieces that are of the same degree, I have to combine them together. Okay? So in order to combine them together, well, I have 3x to the 4th and 5x to the 4th. So I'm going to write 3, let me rephrase that. So I'd have 3 plus 5, and then I'll write x to the 4th on the outside of it. 3 plus 5 is 2, so I'll have, nope, that's not 2. That's an 8. I was thinking subtracting. So I have 8x to the 4th. Okay, so I want to go in descending order. So what's the next highest degree I have? That would be my 2x squared. Because of that, I don't have any like terms with that one, so I'm just going to write it down, and I'm going to copy it in each step. Okay, so next, looking at the next degree, well, I don't have any 1, so I'm going to have to go for that minus 4 because it's my last term and it has no like terms. So right now, my highest degree is 4, so I have my 4th degree, And how many terms do I have? I have 1, 2, 3. So this one is a 4th degree trinomial, using those terms from that last table I provided. Okay, so what I'm going to do is I'm going to give you a couple of moments to go in and do these next couple examples on your own right quick. So write it down on your paper and see if you get them right for when I put the answers up in a moment. Go ahead and press pause now so that you can work through these before you get the answers. Okay, so hopefully you've now gone through and now go check your work. See, did you get them right? Did you get them wrong? How did you do? If you're having parts right now that feel a little confusing, feel free to shoot me an email or ask me questions. I can set up FaceTimes with y'all. I'm completely here to help you out. Doing the practice as we go along through these PowerPoints will really help you be able to work on these on your own when you're doing them later. Okay, so let's keep going. When I want to add polynomials together, okay, what we're simply going to do is we're going to identify like terms and combine all of the like terms together. Okay, so I have a 4x squared and a 2x squared. So that's going to be 4 plus 2, and the x squared will go on the outside of the parentheses. Okay, and so if you want to go ahead and finish up that part, 4 plus 2 is 6, so I have 6x squared. And then we can move on and look at the next piece. Okay, so I have my square term. Now I want to start with the next lowest term. So that's I have a 6 and a negative 9, and they're both x's. Okay, so, well, 6 minus 9 it's negative 3, so I'm going to write minus 3, and I'll keep my x. So last but not least, we have our constants. And so I'm going to have plus, that's going to be 7 plus 1. I don't have a variable to put on the outside of the parentheses, which is okay. So 7 plus 1 is 8. So adding polynomials makes it really nice. So another way that we can do this instead is you can also line up your polynomials vertically. What this will do is it's going to allow you to have all your like terms set up, and it's going to make it easier to combine like terms, and it'll make it already in standard form. And so that would make these pieces a little bit easier to work through. So let's see an example of lining them up vertically. So with this first one, I'm going to go ahead and work off to the side, and I will have my 12m squared plus, I don't have a space for a regular m, so I'm just going to put a spot, and then I'm going to write my 4. Notice in the second polynomial, I do have a regular m, which is why I wanted to leave that 0 space in there. Okay, so for my second polynomial, I will write my 8m where that 0 is, plus 5. If you want, you're also welcome to add in a 0 in the squared spot, because I didn't have one of those in my second one. This will allow it to already be in standard form when you combine it. So 0 plus 12 is 12, keep my m squared. 0 plus 8 is 8, keep my m. And 4 plus 5 is 9. So I've now added that polynomial together, and that is my final answer. Okay, so let's go do it again. So I have a cube this time, and so I would have 9w cubed. After cubes come squares, and I do have a square in the first one. 8w squared. Next would become a linear term. I don't have that one. And last but not least, I have a 0 for a constant. If I go and look in the second one, line it up, well, I do have a 7w cubed. I don't have a square though, so I'll put a 0. I don't have a linear term, so I'll put a 0, but I do have a constant, so I'm going to go ahead and put my 4 in there. So 9 plus 7 is 16, keep my w cubed, plus, I don't have anything to add with 8w, so I'll just keep the 8w. You are welcome to put the 0 in there, but because I'm not adding anything together, I'm just going to leave it off. And then so 0 plus 4 is 4. So now that polynomial is in standard form, my highest degree is 3, so it's a cubic. And I have 3 terms, so it is a trinomial. Still bringing that vocabulary back into play. So with these, let's go look at subtracting. With the way we did subtracting, this is going to help us when we line them up, like we did back when we used elimination. Okay, so first off, I'm going to line all my pieces up together to make it a little bit easier to work with. So I'm going to have my 2x cubed plus 5x squared minus 3x plus 0 for that linear term. Now, because I'm subtracting, I'm going to put that minus on the outside. So I'm going to have an x cubed, then a minus 8x squared, a plus 0, and then a plus 11. So, just like when we were using elimination, we're going to have to go in and deal with that minus. So, remember, that minus is like multiplying that bottom row by a -1. So when I do that to every term in the bottom, that gives me a negative x cubed plus 8x squared plus 0, because that didn't matter if I multiplied it by a negative, minus 11. And now my numerator, I would just copy it over again. So that's 2x cubed plus 5x squared minus 3x plus 0. So the signs on the top did not change, only the signs in the bottom. So what is, remember, in this bottom row, when I go to add and subtract, that's like a -1. So 2 minus 1 is just 1x cubed. Plus, 5 plus 8 is 13, so that's 13x squared minus 3x minus 11. Now, we do want to move away from writing that 1 out, and so our completed final answer would be x cubed plus 13x squared minus 3x minus 11. And that is my final answer for this subtraction problem. So let's go ahead and do some more. So here are your steps for subtracting them. And the only new step is to make sure you distribute that subtraction to the bottom row only. Other than that, it's just like adding. This one only has the one new step to go with it. So take a moment and write down the steps. If you're not finished, press pause, because I'm going to go ahead and go on to the next slide. So let's go and do these two subtraction problems just like we did the addition a minute ago. So I'm going to go ahead and work this one out above so I have more space. So I have v cubed plus 6v squared minus v plus 0. Then I have minus 9v cubed minus 7v squared plus 3v plus 0. Okay, so in this case for this problem, I don't need those plus zeros because both of them were zeros and I didn't need a placeholder for my constant term. So we're going to go ahead and erase those because it means one less thing I have to worry about when I'm subtracting. So now I'm going to go in, I'm going to distribute that -1. So when I distribute it, this will become a -9 plus 7 minus 3. So now out here, I am going to add. So as a reminder, in the in that top equation, I have a 1 in front of those two v's that did not have constants. And that'll help me see the values that I'm adding or subtracting. So I have 1 minus 9, which would give me -8 and keep my variable exactly like it is. Plus, well, I have 6 plus 7, which is 13, and I will keep my variable as is. -1 minus 3 is -4, and I will keep my variable as is. And that is my final answer for that problem. So let's go and do another one. I know some of this feels a little repetitive, but it does help a lot the more practice we get in. So writing the first one out, I have 30d cubed minus 29d squared minus 3d. Okay. Then in my second row, I have minus 2d cubed plus d squared plus 0. In this case, I do want to hold on to that 0 because of the fact that it is important because it's saving a spot for that linear term above it. That 0 doesn't look good. I'm going to redraw it. There we go. So with this one, we're now going to go in and do the exact same thing we did before. So remember, that's like multiplying by -1. So it's going to change the signs of everything in the denominator. So my 2 becomes negative, my d squared becomes negative. You can make the 0 negative, but it's not necessary because it's 0. If it helps you remember to do it all the time, you're welcome to put it, but it does not make a difference. And now because I did that, this is going to become positive. And I will just add them together using the proper signs. So I have 30 minus 2, which will be 28. Keep my variable the exact same. And then remember, in front of that d squared is a 1, so that's -29 minus 1. That's going to be -30d squared. And the last one's a little bit easier because since I have a 0 in the bottom row, I will just have -3d. And that will be my final answer for this one. Okay, so that's going to be the end of this lesson, but let's go ahead and I'm gonna write out what your homework is. It is listed on Moodle and in RenWeb and in the email I sent you, but your homework is on page 495, and you're going to do problems 1 through 18. Okay, so with that 1 through 18, you'll finish the problems, you'll take pictures of it on your phone, or you could scan it as a PDF. I have sent you that information in my email, and that will allow you to help you upload it to Moodle. That way I can get your homework, and you don't have to try and type math stuff up. So let me know if you have questions. I'm here to help. This is due on, today's the 25th, so it's due on the 26th at 3 p.m. Okay, so I will be posting answers afterwards. That way you can check all of your work and see how you did and ask me more questions if you need to. So I won't be taking any late homework because of this. Let me know if you have questions and I can help. Bye, guys.